right, so we have learned some techniques of integration, and we've learned about the substitution technique. We've learned about integration by parts, trigonometric integrals, working with the identities, trig identities, and partial fractions. And these, so these techniques, and there are other techniques too, for finding antiderivatives. And over the years, mathematicians have basically come up with antiderivatives for sort of like standard types of functions and recorded those in tables. Okay, they've recorded them in tables. And in section 5.8 here from the ebook, tables of indefinite integrals are very useful when we are confronted by an integral that is difficult to evaluate by hand. Okay, or if we don't have access to a computer algebra system. But of course, here you're not using a computer algebra system. You are working out these integrals in sections 5.5, 5.6, 5.7. You're working the integrals out by hand. You're not using technology. If you're using technology, that's not what you're supposed to be doing, right? You're learning these integration techniques, and I'm going to need to, as you know, see that you understand these techniques through your work, like for on the exam. And but certainly, students I've met at office hours, I'm seeing that students are doing the homework the correct way. Now, in section 5.8, we are going to use a table to help us find antiderivatives, to help us find the answers for indefinite integrals. Engineers would be able to refer to tables like this, and so you should have practice. And basically here, hold on, let me get the right thing here. They mentioned that a relatively brief, hold on here, class, I got too many doggone windows open here. Okay, a relatively brief table of 120 integrals categorized by form is provided in the reference pages, and there's a link right there. So this is in your ebook, section 5.8, the very first page of that section. They give a link to these reference pages. So if you click on the link, it'll bring up a table, this table of integrals. Okay, and well, these are reference pages. Let me find the let me find it here. Go down a little bit. There it is. There it is. See there, table of integrals. So if you click on table of integrals, it's going to bring up all these antiderivative formulas, and they group it by basic forms. There are 120. There are 120 of these formulas. So for problems in section 5.8, not the earlier sections, but problems from section 5.8, you can use this table of integrals to help you work out the problems. Okay, and there's another way to access the tables as well. If you go in your course content folder, I'll show you here. If you go in your course content folder, one moment, let me get it here. One moment, class. Yeah, if you go to your course content folder here, and you click on that link. Hold on here, I just got to click on the link here for chapter 5. Section 5.8 it says, for your reference, the table, here is the table, attached here is the table of integrals from the Stewart text. So all you need to do, try clicking on that link, that red link, table of integrals, and it should bring you up, it should bring up a table of integrals, like a document that you can download. Okay, so you should, when you click on that link, where is it here? Sorry, I'm trying to find, where is, it should be here. One moment, class. Just give me a moment here. I know there are a few. Just give me a moment here. So I'm clicking on that. I'm clicking on the link, and it brings up the table. Okay. And what I'm trying to do is find the table. Find the table here. One moment. Let me do it another way. Okay. Just give me a moment. Okay, you should be seeing this table. Who is seeing that table? Mario, when you click on the link. Mario, okay, Mario has, okay, good. Please give me a thumbs up if you are accessing this table from section 5.8 in the course content by clicking on the link. Are you accessing this table of integrals in the reference? Taj is seeing that, okay. I want everybody to try it. I want everybody to try it. Okay, good. David has it. Xavier, Jan, Joseph, good. So Sandia, these formulas will be available for section 5.8 on the test. Yes, you will have that table available to you. Yes, you will. Yes, you will. But it's only to be used in section 5.8. Okay, but very good question. Okay, well let's go ahead and let's look at a few problems here. So let me see. Okay, hold on. I got to upload the lesson here for section 5.8. We'll have time here to look at a few problems. So I thought it would be nice that you had had it available as a PDF. So one moment here. Good, here we go. So, and let me upload the table as well, just so we have it here at our fingertips. So there are whole books of tables of integrals that are available. Well, they contain a lot of other things too, but this is just these are just some very common formulas, and some of them right? If you look at the first formulas, the table of integrals, the basic forms, some of those for sure. Okay, so let's go ahead and work through a few problems, okay? So let me give you a moment to copy this example down. Okay, so we're using integral tables to help us evaluate. This definite integral. So we need to find the antiderivative for this 1 divided by x squared times the square root of 4x squared minus 7. So what I want you to do, well, I want you to look at your table of integrals and try to find a formula that is a match. So you know, don't worry about the 2 and the 3, right? This is the you know, this is the indefinite integral. And we have to look through the formulas in the table and try to find the formula that's going to help us uh, uh, get the antiderivative. So look through your table of integrals and let's see if you can find a match. And when you think you have a formula number, chat it out, and then we will we'll explore to see which formula is right. Okay, so formula 18. Okay, let me take a look at, let me just write formula 18 down. Hold on. So formula 18, all right, David, one moment. And, you know, let's just, you know, I appreciate honest responses. Formula 18 is, has the integral of 1 over u times the square root of u squared minus a squared du. And that's going to equal something, okay? So let's see. Well, all right. So I have here, what's the variable? What's the variable in formula 18? I see an a and a u. What's the variable though? What's the variable? Is it the a or the u in formula 18? The integral is with respect to u. So what's the variable? Is it a or is it u in that integral? Well, the integral is with respect to u, so the variable would be the u. Good. A is a constant. So like 7 here, we can think of as square root of 7 squared. So a would be square root of 7. Now the u squared goes with the 4x squared. So if 4x squared, if we thought of it as 2x quantity squared, and we said, okay, well, we'll let u equal 2x, so a equals root 7, and we'll let u equal 2x. I mean, we can make a substitution, for our integral to help us. Okay, then so far so good. But what about the x squared? The x squared here, if u were equal to 2x, then x squared would be u over 2 squared, right? Because if u equals 2x, then x squared, well, x would be u over 2, and so x squared is u over 2 squared, and that's just equal to u squared over 4. Okay, well, we don't have a u squared term here. We have a u term here. So it isn't quite a match. You see what I'm saying? We don't have, it's close. Formula 18 is close, but it's not going to be quite a match. Okay, let's see. Tosh thinks it's formula 45. Formula 28, let's look at formula 28 real quick, and then we're going to go to formula 45. Formula 28 on the left-hand side, okay, formula 28 from the table has on the left-hand side square root of u squared times, in the denominator, u squared, and then times the square root of a squared plus u squared du. So, we have a variable squared here. Okay, we have some variable squared here. And, all right. And, we have a variable squared here. And we have a constant, which can be written, I'm sorry, we have a variable squared here, that's the u squared, and then we have a constant squared. But what's the problem? There is a problem with formula 28. What is the problem? It's not going to quite work. Yeah, that's right, Mario. You have a plus here, and we have a minus here. So formula 28 is close. Good try, Mario. But not quite right. Okay, let's look at formula. So, I appreciate the responses. Now, formula 45, okay, so I'm always looking at the left. I'm always looking at the left and see if it's a match, left part of the formula. So there we have 1 over the square root of u squared minus a squared du, and that's going to be a match. We can make a substitution. We can let u equal 2x and hopefully rewrite our integral so that we can utilize formula 45. So do you see how this works, class? Do you see how this works? Is this helping? Is this helping? Okay, good. Mario says it's helping. All right. Well, let's go to the solution here. So we're going to try formula 45. Think of it like you're finding an integral that looks as close as possible, that's as close as possible a match. You're finding a formula from the table of integrals that's close as possible match to the integral you're working with. And formula 45 is good. Incidentally, if you look at Formula 44, Formula 44 is, hold on here. Yeah, well, that won't work. Yeah, okay, let's just, so okay, here's Formula 45. So what we're going to do is we're going to let u equal 2 times x. We're going to let u equal 2 times x. Okay, and then dx will be 1/2 du. So our integral here will become, through the substitution, which you know how to do, it'll become this new integral. Okay. So since u equals 2 over x, no, since u equals 2 times x, this means that u over 2 equals x. And so that's how the x squared became the u over 2 squared. And incidentally, the limits, the new limits, our u limits, are going to be 6 and 4, because u is 2 times x. So 2 times 3 is 6, and 2 times 2 is 4. That's correct, Sandia. That's correct. That's correct. The 6, we're making a substitution here. We're making a substitution. So that means our x limits have to be changed to new u limits. So 3 is going to be 6, become 6, because 2 times 3 is 6. Right? Let me write it out a little more. Here's 6. That's from 2 times 3. And 4 is from 2 times 2. And then also, don't forget, u over 2 would equal x. And so now everything's accounted for. And this is our new u integral. Our integral with respect to u. Please let me know if you have any questions. Sandia, you're comfortable? You're comfortable? Good, good. Okay. So Eric, why did I let's say let u equal 2x? Well, so I'm focused here on Formula 45, what I have here, and then I'm focused on my integral, what I have. And if I'm going to use Formula 45, the u squared goes with 4x squared, right? Right? The u squared here would have to go with 4x squared. Well, that means that I'm going to have to let u equal 2x if I'm going to apply Formula 45. So let's make sure let me do this again. Let me do this again. So what we're saying here is that Formula 45, the integrand, or the integral from Formula 45, is a match with my integral. Okay, well, it's not quite a perfect match, because here I have u squared, right? I have u squared. Well, I don't have x squared here. I have 4x squared. But if I let u equal 2x, then the 4x squared becomes u squared. You see? And that makes me happy because formula 45 has a u squared here. Okay, good, good. And of course, you know, the a squared here is where the 7 is here, right? The a squared is where the 7 is. So 7, I leave it there, but I know that's going to be root 7 squared. Okay, good. Well, so now we have, let's work with this integral that we have. This is the integral we have. And I can't apply formula 45 yet. I have to just rewrite my integral a little bit. So the u squared over 2, the u divided by 2 over, the u divided by 2, that quantity squared, is 1/4 u squared. So I have here, I have a 1/4 here, and I have a half here. I have a half here, right? So the 1/2 I'm going to bring out in front of the integral sign. And then the 1/4 I'm going to bring out in front of the integral sign. And so now in the third step, I can apply formula 45 directly to this integral. I can apply it directly. And when I apply it, I put formula 45 over the equal sign to say that I'm applying formula 45. And again, formula 45 says that the integral of 1 over u squared times the square root of u squared minus a squared du, that will equal the square root of u squared minus a squared divided by a squared u plus a constant. And so when I apply formula 45, since a is equal to the square root of 7, this is going to be my antiderivative. Are there any questions up to this step here? All right. Who's feeling good? Give me a thumbs up if you're so far so good. Taj is good. Xavier's good. Good. It helps to take this first one slow. Sandy is good. Excellent. Well, okay, so we put in the 6 and the 4, and we have our answer now. We have our answer. We have our answer. And this is what web assigned would want, right? So the final answer then, if we go to the next page, I can distribute, you know, the 2/7 on both of these terms. And so the final answer in the prettiest form would be the definite integral, the value, is square root of 29 over 41 minus 3/14. Okay, I'd like us to try one more problem. Let's look at this problem. We're going to use integral tables to help us evaluate this integral. So what I want you to do is look through your tables, your table of integrals, and find me a formula that you think will work. And you know you're going to have to make a substitution. Okay, you know that's going to be involved, but let's try to find a formula that might work. So let me know when you think you have one. Yeah, I will. Yes, yes. One moment. Okay. All right. Very good. Very good. All right. So let's look at this one. And I'm going to try to do this one now. I might run over 5 minutes. I want to get this second one in, and I think it'll be helpful for you. So I hope you can, I mean, you know, I would appreciate if you could stay an extra 5 minutes. If you can't, it'll be in the recording. You know, sometimes nothing's perfect in life, right? And, you know, I think it's very important I try to answer questions and pace myself and answer questions. But then sometimes I might need a little more time to finish the examples I need to finish. And I think it's very important we do just one more. So this example, let's see if we can find a formula in the tables that's going to work here. There's an arctangent in there, so that's a big clue, right? You got to find a formula that has an arctangent. And incidentally, arctangent can also be written this way. Okay. So Taj is looking in the formulas around the 90s. Okay. So, and there's a block of formulas, inverse trigonometric forms. Okay, so maybe formula 95, maybe. What might be another possibility? Actually, formula 95, that's good. That's good. That is good. 92, formula 92 is a simplification of formula 95. Formula 92 is where n equals 1. So let's try formula 92. What substitution do you think I'm going to have to clearly make here, class? What substitution am I going to have to make? What substitution am I going to have to make first before I can utilize formula 92 from the tables? Use your instincts. You would have to be equal to That's right. That's right. In this case, it would be e to the 15x. But I think Javier meant that, and that's right, Tosh. So let's go forward. Okay, let's go forward here. So formula 92 most closely resembles the integral. And I've written formula 92 out right here. But I have to make a substitution. I have to make a substitution. I have to let u equal e to the 15x power. So when we do that, we will get du equals e 15 times e to the 15x dx. And what I've done here on the right was, I mean, this is our integral here, 15 times e to the 30x power times the arctangent of e to the 15x dx. And the e to the 30x power right here, interestingly enough, I can express that as e to the 15x power times e to the 15x power. And, well, that integral can be expressed as then with the substitution u equals e to the 15x power. My integral can be expressed as the integral of u times the arctangent of u du. And so that substitution's good. And you know, these problems, the numbers are designed so that it's going to work out. It'll work out after you make the substitution. You can utilize the appropriate formula, and it'll work out. And so what I have here now below is I've just written out the formula, and then I've substituted in e to the 15x power. We're almost done here. Are there any questions? Are there any questions at all? How many are feeling pretty, I mean, this is new. This is new to you, but how many are getting a feel for the problem, like section 5.8, like what you have to do? You know, how many are at least getting a little bit of an intuitive feel? I know it's new. Okay, good. Taj is having an intuitive feel a little bit. Anybody else? I hope more of you. Xavier, how about you? Are you getting a little bit of a, are you getting a little more comfortable? Are you feeling a little more comfortable? Okay, a little bit on the fence. All right. Sandia, how about you? Are you, okay, good. And yes, absolutely. Nathaniel, I guess Nathaniel, you're feeling okay, right? More or less. How about you, Nathaniel? Good. All right. And I apologize if I can't call out everybody's name. How about Mario? Mario? How about you? Okay, good, good, good. All right. Well, then let's proceed on here because we want to finish up. Very good. And so WebAssign would take this answer, but the e to the 15x squared, I can write that as e to the 30x. So, I could, are there any questions on this? Okay. If we wanted to, uh, rewrite the answer a little bit, we could write it this way. And this would be our antiderivative. So you see the formula, that formula 92, there was a mathematician who maybe, who knows, a couple hundred years ago, discovered that formula using one of the integration techniques that you've learned and said, hey, I want to help other mathematicians when they have to do an antiderivative like this. So I'll put my discovery in a table of formulas. I'll add that to the table. And so that's helpful for scientists and science as a whole. So it's a very wonderful thing, very wonderful thing. Are there any questions? Okay, well, I'll let you copy down that real quick. And let me see here, one moment. Just give me one moment here. Okay, I'll stop the recording then.